hilly topography. Those are called the slick hills. And as you go further north, if you look in the distance, everything's getting really flat. And that's the Anadarko Basin further north. And that I think is the deepest sedimentary basin in North America. Does anybody think I'm wrong?
That's correct.
And at times the world's deepest petroleum well is out there, and at times it's in Russia. Every once in a while one of us gets a little farther ahead, you know, or deeper.
31,000 feet was 31,000 feet was Lone Star Basin out there.
Wow. So this is called the frontal fault zone. This block that we're looking at, it separates the main Wichita Uplift from the Anadarko Basin further to the north. And there's two really important faults. One of them is called the Meers Fault that runs along the Meers Valley here. In fact, where we were looking at Saddle Mountain, that was the northernmost bit of granite, and then you could see hills a little farther north. Those are the folded Cambrian and Ordovician rocks, and the Meers Fault's going right through there. And it looks like it was a gigantic reverse fault in the Pennsylvanian that brought up this igneous stuff and thrust it on top of the stuff to the north. And it's a recent fault, though. It's been active recently. There's Holocene offset along it. It forms a little fault scarp that's visible from the air. There have been a lot of seismic studies on it. There's people here that know a lot more about it than I do. But it's kind of interesting. It's one of these long-lived faults that is still kicking away today. And didn't they at one time where they were planning to build a nuclear reactor out here somewhere? And then they started to realize they were building it on an active fault.
That's what funded all the research on it, was evaluating the seismic hazard. It moved roughly 1,300 years ago, and be about a magnitude 7 earthquake. You know, you got to climb up on the scarp. It's about this high, and we can trace it almost to the end over here. Recent, one of my students, part of his dissertation, the relatively detailed aeromag survey allows us to really connect the dots. It's 90 kilometers. You can walk the scarp for about 35 kilometers, and it has another movement that's fairly well documented by trenching at about somewhere roughly twice 2,600 years, and then a more arguable third one. So we've had a magnitude 7 every millennia or so here. Wow. So it's little. We're having all those little ones up in central Oklahoma, and I'm going like, the one I'm worried about, this mother over here.
How's it dated? Is it radiocarbon?
I don't know all the techniques they used, but it was, you know, in trenches. And
I think that's right. I think it was radiocarbon in the trenches.
Yeah. So they did 2 trenches here, just more or less right out there.
Well, so speaking of tectonic inheritance, we know it was a Pennsylvanian reverse fault. Is it possible it was reactivating the Cambrian rift fault?
Yeah, the funny thing is, it's up on the north. You know, you somehow or another, I don't know, my intuition for what that's worth, not much. I would have expected to be
up on the north. That's the 1,300
year
movement.
Yeah. So, but it.
Well, in terms of the Pennsylvanian displacement, it's not too much.
Yeah.
What's the Pennsylvanian displacement across the Meers?
Well, I don't think we really, you know,
I don't think it's no.
Okay. Okay, so you're looking at the frontal fault zone there with all these folded Cambrian Ordovician sedimentary rocks, mostly Arbuckle group, underlain by the Timbered Hills group, which is Upper Cambrian, that then rests on the Carlton Rhyolite. Some of the hills out there are Carlton Rhyolite. We're going to see a road cut at one of them. I can't really figure out where the rhyolite ends and the limestone begins. The vegetation doesn't work as well this way. But if you see these, we're going to drive up there, and if you start looking at some of those Arbuckle group rocks, they're really complexly folded. They're just beautifully folded, because you have this, and this was the point made in Ham, Denison, and Merritt, that you just got this massive block of igneous material that was reverse faulted to the north, and all those layered rocks just crumpled completely. So they're just incredibly folded, in contrast to this, which shows some internal strain and some brittle faults and stuff, but it's really an interesting structural contrast. That's one of the synthesizing ideas they had in that bulletin that they had in '64. And then further out, you lose those hills. The other major fault is the Mountain View Fault, that's present only in the subsurface, but that's got quite a lot of structural displacement across it, because where we are, we're going to be in Carlton Rhyolite, and then you can get Carlton Rhyolite several kilometers further north. There's a northernmost little hill of rhyolite out there, and you can stand on there and look across the Anadarko Basin. So you're standing on rhyolite, and right from that rhyolite, the Mountain View Fault is about 9 kilometers further north. And if you went 9 kilometers further north from Randy's and his colleagues' geophysics and subsurface information from other places, that rhyolite would probably be about 10 kilometers down. So that's 9 kilometers north. The rhyolite you're standing on is 10 kilometers down, and that's a lot of offset in a short distance. And then if the Carlton Rhyolite is out in the center of the Anadarko Basin, and the geophysics suggests it could be, it would be even deeper than that, because it hasn't been reached. There's still an Arbuckle group at 31,000 feet. So the total displacement across this frontal fault zone is world class. This is really serious tectonics.
Richard, that 31,000 foot well was actually in
Even the hunting.
Oh, I'm sorry.
and they encountered liquid sulfur.
No, I remember that.
They could be getting close to hell.
Close enough.
We have the core in our core library.
What do you think is the deepest that this area was buried?
Oh, this one. Oh, the interesting thing, you know, we're all seeing Pennsylvanian tectonics. But when you had this big rifting event in the Cambrian, when you took the heat away, you got your classic thermal substress. So if you do isopachs on the Cambrian Nordovician stuff, like the Arbuckle group and the higher before the Pennsylvanian, I think we're standing pretty much in the deepest part of that subsiding. Isn't that right?
Yeah.
It is, isn't it? So we're actually in the deepest part of the thermal substance. I mean, the thermal substance.
You're just quietly standing back taking embarrassing pictures of everybody.
Well, from the ice effect.
I know what you're about.
The Timbered Hills group, the Arbuckle group, and everything up through the Hunt and what? Mississippian problem. Because it started getting uplifted in the Pennsylvania. And when did it first start getting uplifted in Pennsylvania? Do we know?
It's mainly the evidence from the Ardmore Basin, where they looked at it very clearly. And it moved first, and then the Arbuckles were formed a little later. So it didn't all happen at once.
But it probably started fairly early on in Pennsylvania, didn't it? You start getting granite wash pretty early, don't you?
And the answer is yes.
Yeah, 100 meters.
And you can see in the granite wash traverse, the first stuff off is the limestone. And then you can see a gradual unroofing on the mountains.
The rock.
But you must have had thousands
No.
up the Cambrian and younger.
Like it's totally different.
Oh, yeah.
From the ice age.
Well, you know, we think of the Arbuckle group as being
What's the ice
looked at in the Arbuckle. But the type section of a number of the Arbuckle units, the Kinblade and the Signal Mountains are from here,
People have done this all over the western U.S.
from these hills.
Great.
So then it was uplifted probably repeatedly in Pennsylvania along these faults. And the last bit of uplift is probably early Permian, because that's where they get the last kind of summer. And after that,
Yeah, it's uranium, thorium.
I suppose they're saying probably more and more Permian came up and probably
And you're gonna date, you're not
maybe
not
Triassic.
Yeah, I'm not.
And then they, a lot of people feed the Oga rocks.
It's just like wind rocks.
So this was pretty buried.
Yeah, it's exhumed topography.
It would be
It's a fossilized Permian landscape, but I don't
the
think
whole
it's
slope, especially with the road.
substantially modified, especially if it was covered until the mile twice.
They take forever, but you could do it.
Yeah. They'd probably do